Hi everyone, welcome to today's presentation. In this video, we are going to learn something on uniform circular motion. And to begin with, the first question, we are asked to differentiate between speed and velocity. And then the question that follows is, a body of mass 200 grams is tied to a string and whirled in a vertical circle of radius 1 meter with a speed of 4 meters per second. Then calculate angular velocity, the tension in the string at the highest and lowest position of the body. Okay, let's begin with the first part. Differentiate between speed and velocity. Now, speed is a scalar quantity, whereas velocity is a vector quantity. So that is as straightforward as that. So let's move to part B. A body of mass 200 grams is tied to a string and whirled in a vertical circle of radius 1 meter with a speed of 4 meters per second. Calculate the angular velocity. We have a body being whirled in a vertical motion, and the radius you are told is 1 meter. So as it moves around, what we are asked to get is the angular velocity, that is represented by the letter omega. Remember, as the body moves around the circular path, at each point on the circular path we have got the linear velocity, which keeps on changing. Now, the linear velocity and the angular velocity are related by the equation v is equal to omega r, where r is the radius of the circular path. Now, in this question, we are asked to get the angular velocity, omega, and therefore, making omega the subject, we have v over r, and v we are given as 4 meters per second all over the radius, and the radius we are told is 1 meter. So when you work out this, you are going to get 4 rads per second as the angular velocity. Next, we are required to determine the tension in the string at the highest and lowest position of the body. So we begin by drawing the sketch. So we have the body at the lowest position, let's call it Y, and the body at the highest position, let's call that point X. So this is the center, and the string, the tension on the string, let's call it TX, and here the tension on the string, let's call it TY. So at the highest point, we'll say, by Newton's second law of motion, force is equal to ma, which is the resultant force, and ma will be obtained by tension on the string plus the weight of the string. Remember, they are both acting in the same direction. Let's call it mg, mass times gravity. So tension plus mg, so that the tension at x is just ma minus mg. Now mg crosses and we have that. The acceleration here is gotten by v squared over r, then we have minus mg. Substituting, m we were told is 200 grams, that is the mass of the object, and 200 grams in kilograms is 0.2, and then we multiply by the velocity. The velocity was 4 meters per second, that is 4 squared, and then we divide by the radius, which is 1 meter, and then we subtract the weight of the object, and the weight is mass, which is 0.2, times the gravitational constant, which is 10, and this should give us 16 times 0.2, that is 3.2, and then we'll have to subtract 0.2 by 10, that is 2, and that gives us 1.2 newtons. Then at the lowest point, that is at y, here the weight of the object acts in that direction, which is opposite that one of the tension. So the resultant force MA is equal to tension on the string minus mg. So we are subtracting here because they're acting in opposite directions. Well, at this point, the tension on the string will be obtained by having MA, and this comes this side so that we add, plus mg. And again here we'll have mv squared over r, just like we had earlier on, plus mg. The only difference here is that here we subtracted and here now we are adding. So what we got at this point when we substituted, we got 3.2. Let me just substitute. Oh, sorry, this is plus. And finally, that gives us 5.2 newtons. And with that, we have come to the end of this problem. Thank you for watching. See you next time.